Yo! Good evening, folks. Oop, need to adjust the volume a little bit. There we go. How are we all? Neds, hey Chris, haven't seen you for a while. How you going? Good evening to you wonderful people. Thank you for joining me. It's been one of those days. Bit all over the place. What's going on? Time for a bit of streaming, bit of dev. So, exciting news is since the last time we streamed, finally made it to Twitch affiliate. How exciting is that? So now, like, we can do emotes and stuff, which apparently is what all the Twitch kiddies do. I don't even know what that means, but I added an emote, and I'm going to figure out how to use it on stream. Ooh! Someone's just like done the full subscribe live thing. Sato TV. Thank you for the sub. That's the first one I've said live online. It's fantastic. Thank you very much for that. That's awesome. Emotes. Feels good. Thank you. Thank you very much. Mongo. Mongo's here. Archbishop's here. Eighth's here. Chris is here. Catching up on the series at 2 times speed on YouTube. That's wise. No one wants to hear me real time. You should speed that shit up for sure. But thank you all for coming along. I really appreciate it as always. Now, hacking/deving without tea is very uncivilized. So tonight's brew is a fairly strong orange pico. It's again another T2 brew. Found though with these leaves I have to put more leaves into a single cup to actually get the flavor. With a standard sized spoonful, it's a little bit weak. So pro tip, add more tea if you're using orange pico. I'm just head bashing my way through group theory. Oh, that sounds glorious. Oh, my finger. He picks up on that. So, let it be known that I'm a little bit of an avid rock climber, even though I'm not very good at it. So, but I was getting to a point where I was like rock climbing a little bit too frequently. So, both of my index fingers had effectively the equivalent of an RSI, and my tendons have just been under way too much strain. So I haven't popped a tendon or anything like that, but there's a chance that I've torn or gently damaged one. And like this finger in particular, if I rotate it slightly or put pressure at a slight angle, it hurts. So it's bandaged up and it's got anti-inflammatories and things like that applied, so that hopefully the swelling and all that sort of stuff is going to go down. So long story short, too much climbing. That's what nailed my fingers, but I've just bandaged this one. So, but I'm gonna put some climbing videos together. I got a funky new camera recently, and I'm gonna make some videos with it. So if you're interested in rock climbing, that's gonna go obviously on a different YouTube channel. But why not, right? Why not? But thank you for asking, and +1 for the observation. All right. So. Amen to that. Alrighty. Now let's get back into it. So where we left off last time, we just started working our way through deserializing configuration that we know we're going to receive at some point during the staging process. Can you imagine if I did only do the hunt and peck typing? drive me nuts. I remember contracting alongside developers who didn't know how to touch type, and I thought, man, these guys, they charge by the hour, but they type so slow. It's just unbelievable. Alright, so let's move over, get rid of my ugly face, and we will move over to VMware. So let me open this up again. The only reason why this wasn't left open is I closed it because I copied the source over to another VM to push it up to Git. But everything else is as we left it. So the last time, I think we had a very simple transport deserialization mechanism happening. And we're at the point, I think now, where we need to go back and have a look at how, like what the next section of the configuration looks like and begin parsing that. Okay? Number of comments I've read from people who don't speak English very well. Most unreasonable. That makes sense. Anyway, let's begin. No dark chocolate for me today. I'm being a good boy. It's very easy to eat way too much of that stuff. Alright, so let's quickly duck back to our implementation. Now at the moment we're not going to worry about dealing with multiple transport types. We will get to that afterwards, but what I want to have a look at here is once we've created our session block and we've done our transport block, you can see that all the transports end with a null terminator, which is what we already know. Then we generate configuration based on the extensions that have been specified. Hey Killix, thanks for coming on, mate. So what we do for each one of these extensions, as you can see here, let's go back to where the extension block is. We have the name of the extension, which, oh, I see what we're doing here. So file extension, go through each one of the extensions, append whether it's x64 or x86. So this is something we're going to have to tweak. And for each one of these extensions, we need to go and load them up. So here you can see we've got this Metasploit payloads Meterpreter path. Now this Metasploit payloads reference here is it's a reference to a class that's baked into a gem. That gem is called Metasploit payloads, and it is responsible for wrapping up all of the payloads. Now if you have a look in your, if you use something like RBM or something along those lines, you look at the history of all of your Ruby versions, you'll find a bunch of Metasploit payload gems installed, and they're actually pretty big. So once you've installed a new one, it's actually a good idea to go and get rid of the old ones. Anyway, so what this does here is it says, go and load this off disk, okay? And it will return two things. It returns a reference to, like, basically the body of the extension and an offset. Now this offset in this load RDI DLL function basically says this is the offset from the start of the payload to where the reflective loader function is. So that's very specific to Windows. Now we're going to have to abstract this just a little bit because, as you can see, I mean, because this is under payloads Meterpreter config, if we just went back to here, you'll see that there's a under Meterpreter, this config is the only instance that we've got. We should be doing different things for different versions of Meterpreter. Rasta has subscribed. Thank you, Rasta. You're a legend. You can emote too now. I don't know how to do that. Hey, Codingo, thanks for coming along, mate. Can't believe I've got like subs and stuff. It's all very exciting. Actually, we should do the emote thing in just a minute. I don't even know how to do emotes, but those of you who have subscribed can probably teach me because I'm really lame at this sort of thing. All right, let's go back to where we were. So what we need to do is we're going to make the assumption that this doesn't matter. And as you can see here, the extension data that we're actually packing is just the length of the extension followed by the extension itself. Okay, and here we're using pack V again, so we're not doing the endian thing. And as a result, we're actually ignoring this offset. That's actually only useful for certain scenarios, and that's why this load RDI DLL function returns it. But at the end of the day, we don't care. Okay? So, yeah, thanks, Rusty. You're a legend, my friend. You are a legend. So what this is basically saying is, for every single extension that we're baking into our payload. Now, this isn't actually something that we need to worry about as part of our staged config because we don't get given any extensions, although we should actually provide the means to do that. What this is going to be used for is stageless payloads, okay? And stageless payloads are a whole different ballgame, but we'll get to that. We still have to handle parsing of that configuration at this point, okay? So that's what we're going to do. What we're going to do is I'm going to go back here. I'm going to open up our server. Okay, so once we've loaded transports, we've gone through all of those. We're going to go and load extensions from the same reader. Okay. All right, private void, load extensions. Oh, look at that. The control N thing works now. Binary reader. Actually, I wonder if that's true. So let's just put a string in like this for a second. Because the whole point of the control N thing, there you go. See how control N was able to parse this string and pull that out of the current file and use that as what to auto-complete the current identifier. Now you don't get that in Visual Studio by default. That's a Vim thing. So for example, if we said, I'm going to call this variable something really big and long and I don't want to type it again, then I can start typing it here and press Control N and it matches it. So even though it's in a comment or it's baked into a string, we kind of get like an IntelliSense thing baked into it. So there you go. That's the thing that I was trying to demonstrate on last stream, but for some reason it wasn't behaving itself. Maybe the restart of Visual Studio made it fix itself. So anyway, so what we want to do here, something really big and long. Yes. Very funny. So what we're going to do is, as you can see from the configuration, we basically loop until we get to a 0 length configuration size. Extension size. So what we need to do is read the size, and for each one of the sizes that are non-zero, we're going to load the extension, okay? Which is actually pretty simple. So we're going to go var size equals reader.read uint32. So we know it because it's packed with v, we don't have to do the endian thing. And then we're going to go while size is not 0. Now this is really important. I'm going to put the loop terminator in straight away. Size equals reader.read. There is a little bit of duplication here. I don't know why I've done this. But that has to be in the loop, otherwise we get stuck in an infinite loop. Okay? So while the size is greater than 0, off we go. I see a bug, but I don't know if it's an intentional educational one. Go on then. Come on, you know you want to. Mongo, sing it out. Sing it out when you see it. Yeah. Is it a C# thing to put the U after the 0? Yes, so if I put the U after a literal number, that makes it an unsigned integer. So because we're dealing with unsigned integers here, I'm just explicitly saying I expect that to be unsigned. Ah, yes, but am I? So that's a really good question. So when we load the transports, you see how I've got this peak char? You're right, we're not actually catering for it. So there is like an extra couple of bytes that we effectively need to skip. And yeah, I was kind of hoping that we would stumble across that, but yes, we do need to cater for that. You're exactly right, Mongo. So we've peaked it, and now we need to skip it. Reader.read uint16. Now we know it's 2 bytes. skip the terminating. Let's do this. At the end of the transport list. Thank you, Mongo. Does everyone understand why that's the case? So when we're generating the transports, we terminate the transport with an effective null wide character. Okay? And what Mongo is rightfully pointing out is that we were looking, and while we've actually got a character to read, a valid non-zero character to read, we're going to go and load the transport. And from there we actually need to read. Once we've actually gone, oh look, there's 2 nulls, we must have reached the end, we've got to skip them. So that's why we're doing that. Hey Jay, thanks for coming in, mate. Okay, so while that's the case, we then basically need to go the extension bytes, so the actual bytes that are wired in from the extension that's been loaded into the configuration. We can just read those read bytes. Can't even type. Size. So however many bytes we've been given. Now size is a uint and we're expecting an integer. I hate that. Why would you want to specify a negative size? Like seriously? Reads count bytes. I just don't get it from the current position. Does it mean like if you specify negative, it reads in the opposite direction? Is that how that works? I don't understand why would you ever want to do that. Anyway, so private void load extension. We're going to go byte array extension bytes. Now, I'm not actually going to do anything here. Just going to leave it to do. Implement this. Because that's going to be a core part of some things that we actually want to be able to do kind of on the fly. And this function may not necessarily exist in this particular scope. We might have like an extension manager or something. But some kind of utility to manage the loading of these types. And we've got to come to that later on because 1, we don't have any extensions to load. 2, we don't actually have the means to generate this payload yet anyway. And 3, when it comes to making these extensions, we're going to have to do some interfacey related shenanigans to make them function correctly. Okay. Oh, how good is tea? Excuse me. I know you're there, Dean. You haven't said hello or anything yet, but I know you're there. I feel your presence. Thanks for coming in, buddy. Okay, so hopefully that makes sense. So what we'll do here is we'll go load extension bytes because of that. That will go off. And what we will be doing there is once we've chosen the method that we're going to use is we'll take those bytes, we will load them into the current CLR in whatever way, shape or form that we think is fitting. And from there we will decide, we'll basically be able to interact with that as code, so to speak. If that makes sense. So there's a couple of things that we want to consider there, and we will come to those when it comes time to actually load those extensions in the first place. Okay? And this all comes back down to app domains and, you know, all this other funky stuff. Pardon me. Okay. So we pretend to have read our extensions. This code should actually function. So let's go back to here and kick off our tester. Building. Come on. Right, so we know that we have the ability to load the session based on what we had before. So session goods, expiries, exit funcs, etc. We then load transports, and our current transport list should just have one TCP transport in it, which is fine. Next, we're going to load the extension. So we read the size, which should be 0, and it's not. It's definitely 0, so we don't need to do any more. We can just bail out. Simple as that. So we've effectively done nothing. Okay. Once the extensions is done, oh, there's bits. Yeah, that's right. There are bits. Ooh, did someone just use them? Has used 500 bits. What are bits again? They're like I don't know. Are they a currency? Someone's okay, so you're cheering with bits. Is that how it works? There you go. I am amazed. I don't know what that means, but it looks cool. And there's a little funky icon, which I think is cool. Bits are equal of money. More monies. All the monies. Thank you, Rasta. That's hilarious. Bits go to the streamer. Yeah, right. Man, you've already thrown stuff at me by subbing. So love your work, man. Thank you for that. Righto. So we've terminated the extensions, and then the next thing we do is we have this extension init data, which is kind of funky. You're sharing money. Strippers, trust me, you do not want that. You certainly don't want that live on stream. So we won't go there. Make it rain. Ooh. Gross. Okay, so for those who don't know, the extension init block is actually quite cool. So here's an example of a use that I have all the time for this. So currently when you construct both a staged or a stageless Meterpreter payload natively, you don't have the ability to say, I want to have multiple transports in my stageless payload so that when Meterpreter kicks off, if one of the transport fails, I can roll straight over to the next one. So you can't sort of specify, reverse TCP and reverse HTTPS and reverse HTTPS again pointing to a different endpoint. So in order to get around that problem, what I do is I create a stageless payload, and then I add the PowerShell extension to that stageless payload by adding, extensions equals PowerShell. And then I have an extension init, which you can specify basically by doing, let me just fire up Notepad. So the command line would be, if you were using Venom, you'd go MSF Venom P Windows Meterpreter, let's say you'd go reverse HTTPS, right? So you have lhost equals foo.com, lport equals 443, etc. Okay? Now, to add the extension, you would go ex extensions. Now, I always put standard API and priv in because standard API and priv are part of the core payload anyway, as in they are the first two to get loaded when the whole thing is staged after metserv kicks off. And then I add PowerShell. And then I go ext init equals PowerShell. And then, for example, temp add transports.ps1. Okay. Now what this does is this file here is read from disk. Okay. And once these extensions have been loaded, it will go through all of the extensions you've specified. Now let's pretend that you also had, I don't know, let's say you had the Python extension as well. So you'd go, comma, Python. You might also go Python, comma, temp foo.py. And basically what this does is it goes through and loads up all of the extensions, and then it goes through all of the XD inits, and it goes, so the content of that file, right, I'm going to invoke the initialization function inside that extension and pass in the body of whatever file you've given it. So in this add transports, you might just have a simple PowerShell that just goes, right, I'm going to dynamically add a transport to the current Meterpreter session. Okay? So for those who don't know, the PowerShell extension has a bunch of baked-in scripts. There is a add web transport where you can just go URL HTTPS blah blah blah. You can add TCP transport to I think it's something like this. It might even just be host foo. Let's go bar.com port whatever. Now, the full documentation here. So if you have an interactive PowerShell extension running, and you go, you've got your Meterpreter prompt, and you go PowerShell shell, you'll get a PowerShell prompt that looks something like this. If you type get help, add web transport, just like you would in a normal PowerShell prompt, it'll dump out examples. If you put full here, it will dump out examples and all the documentation for those functions. So what you can do is you can add these, like so, to an external script, wire it into ext init, and before, this is really important, before Meterpreter actually attempts to connect back on the first transport, this will execute. So that means you can have your default transport, which here is reverse HTTPS. You can add extra transports, but none of those transports are touched until they've all been loaded. And then the default transport will be tried, and then if it fails, it'll roll over to the ones that you've added on the fly. It's pretty cool, hey? So that's what the ext init thing does. And it's pretty dumb. It just says, you tell me a file, and I'm going to assume the contents of that file are interesting to whatever it is that the extension is happy to use. Yeah, it's pretty cool. I've used this a lot, and it's super handy. And it's kind of nice because you can by default point at foo.com, and when that gets burned, it just rolls straight over. Hey, that's local. That's absolutely local, mate. So all of this is at payload generation time. So the content of that file is stored in the configuration. Okay, so it's not dropped on disk on the target. It's actually baked into the payload that is sent down the wire. Okay. Because this is actually done during stageless payload creation, is actually baked into the executable, right? So the .exe file or the .dll or whatever it is that you're creating will have this stuff in it, okay? So then you send that, you run it or whatever, and it powers up, loads all the extensions, and it takes the content of your extension init files, which are part of the exe now, and passes them in. So it does the figuring out on the fly of, oh, here we go, we got some bytes in memory here, let's pass those bytes to the extension initialization function, and it can figure out what it wants to do with it. Bear in mind too that this doesn't have to be a text script. Like if there was an extension that took some kind of binary data to Bootstrap itself, then that can be binary data as well. Let's say you had a special extension that just ran arbitrary executables, and you went, xt init my custom extension, and you gave it a .exe. So that .exe would be baked into this .exe, and it would be passed during startup, and it by then might go, you know what, I might process hollow and kick that exe off as part of something else. Like the options there are pretty limitless. But yeah, this is all stored locally, and it's extracted from disk at this time when the payload's generated and stored in the resulting target. So if, for example, we specified -o temp output.exe, exe, not text, then this file would be the one that would contain the content of all of that stuff. Okay. There is some documentation on that somewhere. I might leave this open and add this to the artifacts in the GitHub repo so people have this handy, and I'll show you where this is in the source as well. Okay. So hopefully that's a little nugget of gold that a lot of people out there did not know was there. Oh, Bandit! How you going, dude? Long time no see. I hope all is well. Everything is fantastic at this end. Thank you for asking. Living the dream, as some might say, and the fact that one person has just seen what we're talking about on screen and gone, hang on, I didn't know that was a thing, makes this worthwhile. So that's all good. Okay, so what we need to do in order to parse that, we're going to be doing exactly the same thing, right? So this extension init block, you'll see, where is it? Extension init block. So what it does is it reads the file from disk, it puts the name of it followed by a null terminator, and then the content length, and then the content, right? And then it does the null termination thing at the end. Okay. So that means it's actually pretty simple. What we need to do is load extension initializations. Initializations. Now, for those people in the crowd that hate me because I don't have American spelling, you're just going to have to deal with it. Sorry. I don't do Zs. Just no. Alright. So what it does here is we're going to do the peak char thing as well. So we're going to go while reader.peakchar doesn't equal 0. So we're looking for that null byte at the end. That's right. You can all unsub. Take your Take your bits back or whatever it is. I went and bought a new Mac so you can't hack me. Yes, Barney. Unhackable. Mac's unhackable. We all know that. Righto, so now this is where it gets interesting because we need to be able to read an arbitrary length string. Fly that flag, Tim. So this would probably be the first case where we don't actually have a fixed length set of bytes to read. So the question then would be read reader.read string reads a string from the current stream. The stream is prefixed with a length. Ah, now this is interesting. Encoded as an integer 7 bits at a time. So we can't use read string here. We're going to have to do it ourselves, which is concerning. Now the fact that we don't have a length that we can read means we're going to have to effectively read it byte by byte, right? So what I'm going to do is I'm just going to create a list. Okay, so we're going to go string bytes equals. Now, this is Unicode nonsense, right? So we're going to go list of byte. Because is this ANSI? I think it is. Sorry, ASCII? I think it is ASCII. So extension init block. Yeah, we're not doing any wide character packing. Yeah, we don't bother about specifying this here, so that's all good. Yeah, okay, so this is a case where we just literally need to handle this ourselves. So we have the name as a string, which is an arbitrary length, followed by, you know, the null, single null terminator, followed by the content length, followed by the content. Barney has subscribed. Thank you. Oh, and Dean has subscribed too. Thanks, guys. Man, I'm feeling special. Thank you very much for the subscriptions, people. It's very much appreciated. There you go. Barney's in on it as well. Now, one of you fine people can emote. I was before. Is what it is. Yeah, thanks for the subs. Now, can someone do the one emote that I've set up? Barney, I know that's your thing. It's got to be some information on emotes handy. Alright, so how are we going to do this? We need to be able to read byte by byte. Alright, let's create a new list. And this could be the messy way of doing it, but what I want to be able to do is read. We basically want to be able to read a single byte. Reads the next byte from the current stream and advances the current position of the stream by 1 byte. Now we know for sure at this point that you know what I should do here is rather than peak, I'm going to do the same as we did before. So B for byte equals reader.read byte. Okay. And then we can say while B doesn't equal 0, we can do our thing. Let's put this string bytes here. Okay. Get rid of that. We need to duplicate this behavior. Okay. And now for each one of these things that we read, we want to append that to string bytes. Dot add. No, I don't want a byte array list. I just want a byte list. So we're going to add the byte and read the next one. And then when we're done, the name of the extension, so var ext name, is going to be, let's have a think about what we're going to do here, because I don't want to duplicate code. No, that's not my emote. None of those. I'll dig it up shortly. So the extension name is going to be us converting that from basically an ASCII string. Okay, so encoding which is system.text.encoding.ascii.getString from string bytes.toArray. Okay, so that should give us the extension name. Okay, now we're going to have a to-do here, because basically what we want to be able to do is get a reference to the extension and pass in the init to the init function. Let's just go init source like that. So it for example would look something like this: var extension equals this dot get extension, and the extension, we would be giving it the name. So we're going to have to do some accounting behind the scenes here, and then we're going to go extension dot init and pass in basically the rest. So what we now need is the what would it be? It's the size. Remember, next thing is the size, content length. So we'll call it length equals reader.read uint 32. And then let's say init content equals reader.read bytes int length. All right, so at that point, we just want to do that. Actually, I think we probably want to give it the length as well. No, we don't need to in this case, because we're dealing with .NET. The array itself will have the length baked into it. So that's basically what it is that we're looking to do, yeah? This is begging to be a read null terminated string extension. I was pondering that as well, but I say we leave it like this until we come to a case where we know that we're going to need to reuse it. Okay, so for now we're going to do the simplest thing that could possibly work. The reason why I guess I'm kind of against it here as well is that we're actually consuming the byte as we check along the way. So we may come back to refactoring this just a little bit. Okay. Now, as far as extensions go, we can actually really easily account for these extensions, but every single extension will need to have an interface that it needs to adhere to. The problem is that we haven't yet decided on whether or not we want our extensions to live in different app domains or not. So I'm not going to get ahead of myself. As much as I would love to dive into that now, I'm not going to. We're just going to keep the to-dos there for now. All right. So let's do the same thing. We're just going to debug this. Does that all make sense, by the way? I really want to get into the app domain discussion pretty soon, because it'll be a pretty interesting thing to dive into. All right, so we're going to read the byte. B is coming out as 0, which is clearly obvious. While it's not 0, grab the next one. Here you can see ext name is blank because we don't have anything in it. Length should be basically non-existent. Now this is interesting, because what I haven't catered for is, given that we're actually catering for the case where the extension name is blank, we haven't got an early out. So we're only reading the, yes, that's exactly what we're covering, Mongo, spot on. So we read all of this. And then what we should actually be doing here is checking the length of our string array. Okay. So we should be able to go if, let's go, where are we? String bytes dot length, or is it dot count? Dot count is greater than 0. Then we want to do this. So let's do it all. Okay. So that obviously does it for one extension, as Mongo has already pointed out. But that is not catering for the case where there are multiple extensions. So we want to be able to loop through all of this every single time, okay? Which means that the rejigging of this code is going to be required, which might actually, put us back in the peak char position. So in order to loop through all of this, what I'm actually going to do is invert this a little bit. I'm going to do something you should not really do, is do a do while. Oops. There we go. So do. Let me just quickly renege on that. So while b doesn't equal 0. Okay. We're going to create a new string array every time we do this loop, and we're going to keep looping through. Excuse me. So what we're going to do is we're going to iterate over in the same way that we did before. But we know that first byte is already non-zero. So we can actually invert this into a do while. Okay. So we're going to add the first one and then read the next one. Okay. Now this if condition here, I don't think we're going to... Oh, we are going to need. Nope. We aren't going to need it. Because while b doesn't equal 0, we're going to go through and read all of those characters while there are still characters to read. Then we'll pull out the length and we'll read the content and then we'll add it. Okay? But what we do need to do next is put this in. Read byte down the bottom. Okay? You can tell me something if you really want to, Barney. Okay, so this should come out as 0, resulting as completely skipping everything. Yeah, we can all see it, mate. I know what's coming. Oh, you love me? That's probably the most elaborate troll. Needs to assign it to B. Thank you, yes, B equals. Good catch, Mongo. That could have been emotional. So yeah, we want to read, check to see if we have reached the end. So the good thing about that is that B, if it's non-null, then we'll come back in here and it'll still be non-null. We'll create a new list and then we'll add that first byte to the new list, at which point we'll go around again. Thanks, Mongo. All right. So we've parsed the whole configuration. We haven't necessarily correctly handled every case, but the important point there is that we have the building blocks to parse the configuration when it becomes available. And so that would become available whether we've got a stageless payload. It'll become available whether we've got a staged payload. Will was being bullied by another student and a conversation we had resolved in bullying and he is happy. That's good news. That's good news, man. Bullies suck. Being bullied sucks. So it's good to hear that you got a resolution. Kids don't deserve being bullied. It's not cool. Not cool at all. So thumbs up for the good resolution, mate. That's great to hear. Okay, so here we go. What I would like to do at this point is perhaps flick over to a pseudo/bastardized version of maybe a stager. Maybe what we can do is we can point this at a native stager and go from there. I think that would make sense. I think it would make sense. Anyway, so one thing that I found a little bit confusing based on what I just saw here is this configuration should actually be used for all payloads, including the Java payloads. So what I'm a little bit confused about is like the Java payloads won't support, I guess, sort of this extension mechanism insofar as there's like this extension mechanism clearly only handles .dll extensions. See, there's an old to do here, right? We're going to revisit this. But if we duck back over here, let me just exit out of this. AG config, what was it called again? Sorry, generate config. To be config.to be. Right, so check this out. We do have config.tobe being called from Windows, blah, 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 blah. So all of these stageless payloads, use it, which are all, by the looks of it, Windows, and then there's the Java Meterpreter that uses it as well. So let's just have a quick look at this. Oh, someone just did a thing. Another subscription. Timols, thank you very much for your sub, my friend. That's very kind of you. No, it doesn't. Bandit. It still uses just standard .jar files. Let's have a look. Interesting. So generate config. Let's see. Config op. So it is doing exactly the same thing. But you'll notice, here we go. So we are never passing in extensions. Create the configuration block for staged connections is really simple. Yep. Maybe there is no such thing as the sort of stageless Java equivalent, which there probably isn't. But the point here is you'll see that we're not passing in any extension or ext init stuff to the Java configuration, right? Which is pretty interesting. And this is blatantly me. This is all my horrible code. As you can see, I am the only author of this file. Whoa. Please don't hate me. Anyway, as you can see, there are some... we are effectively doing the same thing. Like, we've got this serialized nonsense which we end up packing together in a Java equivalent. But it doesn't handle native extensions, without a doubt. Yeah, I think so too. Well, that's assuming that Java is running on Windows. But we do have we have standard API, and we have just metserve. So standard API would be the only extension that we would be loading in a Java land. And we have the ability to load that on the fly. We just need to basically do the same thing with whatever extensions are baked into this. Holy shit. What just happened? Wow, Barney, did you really just do that? That's nuts. So I've just got notification that Barney has just given out 10 tier 1 subscriptions. Gifted subs from Barney. So wow. Holy moly. Guess he's something you contractor. Barney, your generosity knows no bounds, my friend. Thank you very much for that. So looks like there are 10 lucky subscribers. There's Mr. 64-bit, Lord Parody, R Primus, Tiles F&Q, Faithx, Bandit, Chris MNZ, Killix, Spamalite, and who did I miss? Medoix, however I say it. Geez, I'm bad with names. That's hilarious. Well, thank you very much, Barney, and everyone else who's in attendance. It's very nice to see you guys getting a kick out of what we're doing. So anyway, okay. So at this point you can see, like, we do have this configuration generation happening here. We should probably pass extension information through here. Now, I'm not going to do that now. We will do this later on. We have the ability in each one of these Meterpreter loaders to pass down the extension for the extension methods that we are using. So here you can see we're baking in .dlls. We can pass that down in our options, so that we, instead of having to figure it out, we can just use whatever it is that we've been given. Oh, he wants to be a mod now. Is that how it is? Okay, Barney, if you figure out how to use my emote, I'll make you a mod. But no banning. No banning. I think it's like OJREEV. No, OJREE followed by... I think that's what it is. Just give me a sec. I'm going to go find it. Where are we? Go to my own channel and make sure that's off. And then we go to... I'm so bad at this. Here we go. Bits and cheering, emotes. And that is... Oh, it's pending. Okay, so it needs approval, clearly. But I think that's what it's going to be. However it is that you invoke those behind the scenes. Anyway, that's what it's going to be. And it's just a picture of me going... And I'm going to do some other ones for higher tiers. If you want to troll me with get system emotes, you're going to have to pay more money. But it's coming. It's coming. Okay, so anyway, back on track. We're going to come back to this. We will have the file extension passed down by the thing that creates it. Hello, Men's. Thanks for coming in, man. Right. JC time. Yeah, that'll probably be the next one. Be a picture of me having a cup of tea. I like that idea. How many emote slots do you get first off? So by default you get one, and one for each tier. And then from there you earn more depending on how many subs. Oh, that's a really key point, actually, because. How many do you need? I'm looking at the settings again behind the scenes. So, I've got another one. Hang on. Yeah, so I can specify another one now because I needed 15 subs and there's 19 thanks to the fact that Barney of the Rubble has thrown 10 subs out to people. So that's pretty amazing. I'll have to come up with another. I might just use your idea, Bandit, and have a tea time one of some description. Hey, look, I am paying dearly in so many different ways, Jay, for having the whole get system thing in the first place. So the least I can do is make it as painful for you bastards to say it every single time in emote form. Anyway, so back to code. Let's get back into it. So we currently have the ability to read our entire configuration block. And when we come time to actually wire in the configuration properly from the other side, we are going to add facility to make sure that we can pass in the correct file extension from whatever's calling it, because that's important. That's because you are a troll. We love you, but, you know, be honest, you are a troll. And that's okay. We're all trolls in our own little way. Righto. Now, with that out of the way, we're back at a point where we can create a server from configuration. And at the moment, the sample configuration that we've got just points to localhost. Now, what I'd like to be able to do quickly is get to a point where we can, through some kind of stager, connect back to Metasploit and parse the configuration on the fly. Okay? So, in order to do that, we need to answer some questions, because staging is, you know, the process of staging is relatively simple, but in order to do this in a way that, you know, we're going to maintain going forward, we need to answer some questions. We want to know, are we using blocking or non-blocking I/O on our TCP ports? Are we using blocking or non-blocking I/O? Sorry, not non-blocking, blocking I/O. For HTTP, are we just going to use the standard polling approach? We're going to basically do the same as what the native Meterpreter does, at which point, yep, that's probably fair. Thanks for coming in, Chris. Always good to see you, man. Look after yourself. It's true, I did say that, Jay. So I think what I'm going to do to begin with, just to make it really, really simple, is we're just going to use a TCP client to pretend to stage pointing at Meterpreter, a Meterpreter listener on the Metasploit side. Okay. Void, we'll go simple TCP stage test. Bear in mind, I'm not doing TDD, right? Now, what I'm going to do is I'm going to write a little bit of code in here that will effectively, potentially down the track, become part of a stager. So this is a pseudo stager. We're going to have a... this is off the top of my head, so I'm going to get this wrong. TCP client, which I think is part of sockets. Yep. Now we can give it a bunch of stuff. Hostname and port, that's what we want to do. Now the host name will be, because I'm lazy. Oops, I'm not on Windows. What we need is the 192.168.20 address, that one there. Okay, and we'll go 4444. Okay, so that creates a new TCP client, which should straight away allow us to open stuff up. TCP client dot. Now we're going to do this directly without any smarts whatsoever. Now if we type connect, you can tell I haven't done this for a while. What does that return? Boolean? Void. Connects the client. So if TCP client dot connected, is that Boolean? Yep. Okay, then we can start reading some data. Okay, now remember the first part of the process when we've staged a DLL of any kind, which in this case would be metserve, is we would read the size off the wire. Now the question here is that size going to be network byte order or not? Now what do we want to do? We've got get stream. Network stream. I haven't used this for God knows how long. We've got something else. Tiny N1 has followed. Thank you for the follow, Tiny. Much appreciate you coming along. Send timeout, get stream, end connect, close, begin connect. Let's just do this get stream. We'll just go S for now. Now what I am going to do, I think that stream will be disposable, so let's wrap it. S dot read. That's what we want. Okay, we've got read byte. So we're probably going to do some extensions. Oh, actually, no, we're not going to do extensions at this point because this is going to be part of the stager, right? Instead, I'm watching you do stuff I don't understand. Join the club. We're all learning here, my friend. So what we're going to do is we're going to go size equals... actually, you know what we should do? I wonder if there's a nice way of doing this. No, I don't think there is. So we basically want to go the size of, you know, the stage that's coming down. So stage size equals a new byte, and it's going to be 4 bytes, right? We know that. So then we should be able to go s dot read. We're going to read into stage size 0 and 4. Now before we continue doing that, let's set up a proper listener here. And this of console, we'll set the L host to 192.168.20.171, and we've just had another follower, I believe. And I'm going to go set exit on session false, and we'll run that as a job. Okay, Who's just followed? Etox. Oh, that's a name I haven't seen for a while. Long time no see, mate. How you going? Thanks for joining in on the stream, funsies. If it is the Etox that I know. So, let's see what happens here. We need to actually call it simple test. Let's see what happens here. I'm expecting to see a connection come through on this side when this happens. So we create a new client and we try to connect. Aha! Check this out. So we have a connection. Is it connected? Yes, it is. Let's get the stream and read the stage size. And that stage size looks to be reverse byte ordered. So we need to basically convert that. I think we should be able to use, is it convert.to int 32 to, or can I do to uint 32 bool byte char date decimal double float long object byte short string uint u long u short. Do we have to use bit converter? To uint 32. Here we go. Stage size 4 bar. Let's just call this. I'm just going to be lazy and call that a buffer, and this is going to be the size. What is a stage exactly? So, a stage is 4 bytes that represents the length of the entire DLL that we've loaded. So the first part of any stage is metserve, and the first 4 bytes tells us how long metserve is. Okay, so the DLL that is metserve that's been loaded off disk. Now this is going to give us a native metserve, and we're just going to ignore it for now. Okay, and in order to pretend that we're doing the same thing, we're actually going to load a local instance of the server and then go from there. Pardon me. So what I want to be able to do is sort of wrap the reader around the network stream, and hopefully from there we'll be able to kind of abstract the whole thing, which is what makes certain things about .NET really nice. Does that make sense? Little breakpoints. Let's go down here and see what the size comes out at this point. So we convert that to, oh, what do we got here? The index data range must be non-negative, less than the size. What have I done? Start index. Oh, that should be 0. My bad. So size, actually, there you go. It's perfect. That's exactly what we would expect it to be. Just under 200k. Remember back in the day when metserve was like nearly a meg? I remember those days. Okay, so at that point, once we've read the metserve size, we can basically read however many bytes off the stream at this point. So we want to go s.read restart from the network stream. You know what I'm going to do is I'm actually going to wrap this at this point. I wonder if I should have just done this here. Using var r equals new binary reader, because readers take a stream and a network stream is still a stream. Makes a lot of sense, right? So metserve size equals r.read. What would it be? A uint 32? Let's run this again. That certainly made things easy, didn't it? And this is why we use abstractions like readers to wrap around streams. Stager is like an intermediate dropper. Not really. Metserve, which is the core of what we're actually building, is what's coming down the wire, immediately followed by the config, right? The stager itself can be a number of things. It could be an exe. It could be a blob of IL that's running. It could be just the snippet of C# that we've managed to get running in an ASPX file on some crappy web application. It could be a PowerShell one-liner. that does exactly the same as what we're doing. But effectively what it's doing, it's taking a very small foothold and pulling the core of Meterpreter down. Tiny, what we're doing right now is we're building a new version of Meterpreter that will run under both CLR2 and CLR4. And we're just building the core of the Meterpreter functionality at the moment, and we're starting to muck around with the staging process a little bit. So is metserve size right? Yep, that looks right. So at that point, now I'm actually going to chuck this out a little bit, because what I want to do, we're going to read the bytes into memory and load them. So what we would do at this point is that we would do something along the lines of, metserve bytes equals reader.read. It's not reader, is it? It's r.read bytes. Metserve size. I might even just make this and int 32, then I don't have to worry about casting, and we can do the same in the other areas as well. So does that make sense, Tiny? You understand what we're doing? It's a pretty big project, and we're taking it in 2-hour chunks over an extended period of time. But hopefully we'll all learn something along the way. And then from here, we would basically we would do the equivalent of, assembly dot, come on, give me the reflection, thank you, dot load. There should be there you go, raw assembly, so it'll be metserve bytes. Something along those lines is effectively what we're doing. Now, we don't currently have the any metserve DLL to ship down the wire, so we're going to pretend that we've been given one. And to do that, we would also need to do something like this dot, or should we say assembly dot get type. Actually, let's do this. Let's pretend it's actually happening, right? So then we get the assembly reference, and then we've got to get the type based on what we know is going to be the name. So it would be something along the lines of met.core.server, right? And then from there, we need to be able to create an instance of it. And I can't remember how to do that, but we'll get to that down the track. Make array, make by ref name. I can't remember exactly what it is. Okay, so that's effectively what we would do. Thanks, Barney. Have a good one, mate. Metserve bytes would be the compiled version of the project we're building right now. That is spot on, Mongo. Exactly that. Okay, so here instead, we're going to go metserve equals new core.server. Or I should just go server. Now, this is really important because we're just going to pass in the reader that we've already got open. Right? Now, that will allow us to, fully deserialize and all that sort of stuff. But what that doesn't do is tell metserve how to continue communicating over the current channel. So we need to come up with a means in which to do that. But what I want to do is just test to see if the parsing of this actually works. So this is our first pass. This is not necessarily how it's going to run. But what I do need to do, regardless, is still read the bytes because we need to skip over it. Okay, so the size is 179779. Let's read that whole lot so we can see the bytes are actually there. Now if we show this in hex, let's serve bytes 45A. So there's our PE header, MZ, that's what that is, right? MZ. So we'll pretend that we've reflectively loaded it, and we're going to jump in here, and let's see if we can actually read proper session information here. So exit func. I don't know whether that's right or not, but let's see what the expiry looks like. Expiry is way out of whack. So that implies that there's something else that's coming down the wire that we've missed. Either that or whatever it is that we generated on the fly out of... hang on a minute. Are they all null? No, that's actually got... Yeah, that should have a session UI. Session GUID. Session UID. They all look like characters, though. Is that right? 639E151A. 639E153C. So that is slightly different. But clearly this isn't correct, right? If we try and load transports here, this is going to be way out of whack. Boom, it's going to sit there and hang. Okay, so that's obviously not what we're looking to do. There's something not quite right about this. So what we'll do instead, once we get to where are we looking to go? We're spitting out the configuration on the other side, right? So once we get here, here's our config. So we should have 1, 2, 3, 4, 5, 6, 7, 8. That's the Q word, followed by 1, 2, 3. That there is the exit func. Right, so let's quickly check again. When we go in here. Oh, crap. I pressed the wrong button. How about instead of that? No! 12. Let's go to here. Now, I'm going to do what we did here before. So we'll set this the next statement, and then I'm going to go reader.read keyword. What does it come out as? Have a look at that. Clearly that is not what we were expecting. That should be completely 0. Oh, actually, should it be 0? Yeah, it should. It should be. Callum is watching and he may reveal himself. He is a self-driven legend trying to learn. Bonus factor for you as he works in a cool place. Awesome. Hi, Callum. I hope you're enjoying yourself, mate. Thanks for tagging along. I'm just trying to figure out what's going on here. So let's do this. Because I reckon that's a string. Oh, no, it's not. Now this clearly is not representative of anything that we're seeing here. It looks like we're not even close, right? 179,779 bytes. Now according to this length that we had before, oh crap. I need to go back to program and actually have a look at the size that's being read. So according to metserve size, let's stop showing things in hex for a minute. 179,779. Sending stage 179,779. Yeah, right. Okay, so... Right, okay, I think I know what's going on. Yeah, I'm pretty sure I know what's going on. No. No, I don't think that's it. There is a pointer to the configuration block wired into the stager. Into the stage that's generated, I should say. So the problem that we've got now is that the Meterpreter loader as it currently stands, this is kind of how it works. Let me get Notepad open again, just so that we can explore this a little bit. And actually what we'll do is we'll look at this. So check this out. This is the header of the stage that's currently being passed down. So, sorry, the stage that's been passed down. So, as we saw before, when we stage Meterpreter, we're loading metserv off disk, and then we're generating some assembly. And you see this load RDI DLL that returns the offset. That gives us the offset to the reflective loader function. You see we're actually passing that in as RDI offset. We've also got this length parameter. Now this length parameter is actually really important because when we pass that value into the assembly, you'll see. So this is the thing that's patched right at the start of the DLL, okay? So all we're doing is some standard crap here, making sure that things look like a PE header as they currently stand. And then we store a couple of pointers for various reasons. Then, based on the RDI offset we've been given, we invoke the reflective loader directly, and that returns a reference to DLL main. Okay? Now, this is important. What we do in order to figure out where... see this offset from reflective loader to the end of the DLL? Add EBX, whatever that value is. That takes EBX and points it right to the start of the configuration block. Okay, does that make sense? So inherently a pointer to the config block is baked in. So in this scenario, you'll see how we've got right the current socket handle to the config. So EBX points to the start of the config. If we have a stageless payload, then we want to take whatever the current socket handle is and bake that into the configuration, because a stageless payload would read that out. Okay? And then to carry on, all we do is call DLL main, and you'll see that we push EBX. Push EBX for DLL main. So when we call DLL Metasploit attach, we pass in a pointer to the configuration here. Okay? Now in .NET land, we are not executing this shellcode. We don't actually know where that is. So this Meterpreter loader, we're probably going to end up having a payload .NET Meterpreter loader or something along these lines, because we're not going to use reflective loaders, and we might not even use the default Windows payload. We might have a completely different type. The architecture, the platform, all of this stuff is going to be really tricky because of the way that this works. We might actually just have to use the similar approach to what's done with Python and PHP and all those bits and pieces, right? But none of this will make any sense. And so what we probably want to do for our Meterpreter loader is we want to stage Meterp and the config, but maybe what we should do is specify two sizes as part of what we pass down first. So the first size will be the size of metserv, the second size will be the size of the config block. So rather than adding the two together as one whole thing that you need to read, it'll read 2. Does that make sense? I know a Callum who's... Ah, wow. Check that out. Ferrety Rug, I assume you're Callum. And yes, the world is a very small place. Isn't that amazing? Isn't that amazing? That these two people just happen to know each other. Does Callum work at Penrith Whitewater Stadium? That's hilarious. That is hilarious. Okay, so what we're saying here really is that we currently don't have the means to point an existing payload, our current payload at a native listener. What we could do is be cheeky and try and parse it out of the code that's generated, but that's just unnecessary because we're never gonna leave this crap in the way that it currently stands. So our plan to connect our current metserv to an existing listener is effectively gone. We can't really do that. We do want to take the same approach, or at least a similar approach. So perhaps what we should do Yeah, I don't know. Maybe not. I'm just trying to think of the nicest way of keeping this very consistent. Because if we look at the way that the Java Meterpreter loader works, like we were doing before. Let's just do this. Payload Java Meterpreter. I'm pretty sure it's here. Here we go. So stage Meterpreter just loads it. You see the blocks are different. Default stage. Okay, where's generate default stage? That must be a Java specific thing. So these are the class files. So look, you know, the Meterpreter loader itself, I guess behind the scenes, it doesn't really matter. We can choose what it is that we want to spit out. So maybe right now it's even worth going, you know what? We might even look to spin up our own type. It might be worth at this point creating something on the MSF side that we can actually start talking to. Should we do that? No, I think that's probably not a wise move. Look at you guys go. Alright, so we'll put this one on ice for now. I mean, we've demonstrated that we can basically wrap our stream up in something that's really nice and easy. And maybe we will use a blocking TCP style approach like what we're doing here down the track, and we'll just have that running on a separate thread and have something that manages it. I mean, ultimately it would be good to have asynchronous I/O happening for this stuff. Excuse me. But it is what it is. Alright, so with that being said, we now need to come up with... Let's take a step back and talk about what we're going to do with extensions. And that's for every extension. Now, as I mentioned to you before, when you have extensions that you load, you can load them into what's the current app domain. And in .NET, an app domain is kind of like a isolated area inside a process, and you can have multiple app domains. And if one app domain cops an unhandled exception, it gets torn down, but it doesn't take all the other app domains with it. So the pros of that are, if you load an extension in a separate app domain and you isolate it in that separate app domain, then if it misbehaves, then it can die quite happily and you don't have to worry about it. If it's in the current app domain, then it'll rip the whole process down. The problem is that if you handle each of these extensions across their own app domains, then it comes with a number of other caveats. So in order to communicate across app domains, you can't just sort of pass in a reference to an object. Like if you had, for example, something like a Meterpreter configuration, you can't pass a reference to that object over the wire of to a different app domain. You have to basically marshal across the app domain boundaries. So what that would mean is, once we've got a byte array that represents a TLV packet, we would have to go, okay, which extension is responsible for handling the command inside this TLV packet, and then pass that TLV packet across the boundary, basically as a serialized array. So then on the other side of the app domain, they would have to deserialize that into their own instance of a TLV packet, do their thing, create a new TLV packet which they pass back across the app domain boundary for the server to spin up into an actual packet with the encryption and all that other nonsense, and then send that back across the wire. So that's one thing that could be done. But as you can see, there's a few hoops to jump through. There's like multiple deserializations required so that you can look at the command that's baked into the packet. It's not necessarily as clean as you would want it to be. There's also other nuances that we would have to worry about. So, are we trying to support existing extensions? No. All the extensions that we would load would also be rewritten. We're going to be rewriting standard API in .NET. We're going to rewrite Xtappy in .NET. We're going to rewrite the PowerShell extension in .NET. Crazy, huh? The PowerShell thing is going to be really easy because the .NET work is already done. So yeah, this is all going to be like actual .NET code that runs as much as possible. We obviously have the ability to load native extensions, but interacting with them is going to be a pain in the butt. Okay, a new Kiwi and Mimikatz was going to come up. That may well be not doable because I'm not porting Mimikatz. I'm not going to port Mimikatz to .NET. That's going to be that'll be a huge job. So you know, that's one case where we literally can't port that extension. So I mean, that's the reason why it doesn't exist in a Python Meterpreter that runs on Windows. It doesn't happen in Java that runs on Windows. Yeah, so you know, maybe we could set a Patreon goal for doing a .NET rewrite of Mimikatz. But you know, at the end of the day, that's a very big job, and Bag's not doing it. So what we would look to do in those cases where we know there are extensions that we can't effectively do a rewrite to. I mean, we may even find the incognito extension, the SBO extension, like those things we may not be able to rewrite. But for now, what I really want to do is I want to get MetServe, I want to get Standard API, I want to get Priv. Those things all need to be done in exactly the same way. They're all definitely portable to C#, to .NET. And so that's effectively what we're aiming to do here. $1 million Patreon, £1 million Patreon goal. Yeah, that's pretty epic. So my gut feeling right now is that the overhead of dealing with separate app domains is not necessarily worth the pain. And so my feeling is that we should just work within the current app domain. And then at the very top level, what we can do is we can go, you know what, if we do want Meterpreter to run in its own app domain, then that's pretty easy to do. And we can sort of take it from there. But I think all of the individual extensions, putting them in separate app domains might be a bit overkill. And so then to me, it becomes the job of the stager to launch a Meterpreter server in its own app domain. Either that, or when the server is created, it can go, right, I'm going to spin up a new instance of myself in a different app domain. And that's effectively a one-off that's done at the top level. And then from there, we're kind of good to go. Okay, so I'm going to assume at this point that we're just going to work within the context of the same app domain. Okay, incognito equals yeah, look, there's some fantastic stuff in there. And I think a good chunk of the code that's in incognito can quite easily be ported. You just wrap all invocations to the extensions in a try block and get the same effect, right? Yeah, yes and no. What I kind of would like to know is at least have visibility of what's gone wrong inside the current app domain. So, you know, get to the point where if a extension is misbehaving, then MetServe knows about it and unloads it. Righto, so what's quite funny about this is that I've got a namespace called extensions. Shit. But what I'm going to do is I'm not going to refer to extensions as extensions in this sense. We're going to have an ext, and that represents not extensions to existing classes, but, you know, a plugin, so to speak. And what I'll probably, and actually, you know what, let's call them plugins in this particular context. So a plugin is something that's coming, like a standard API is a plugin in our context, and that sort of fits more with the .NET sort of jargon. I was going to say nomenclature, but I hate that word, nomenclature. It's a horrible word. So let's quickly put some basic structure in place here. Plugin. Plugins. Plugin. Plugin. So, I mean, at the top level, handling these plugins is actually going to be very simple. And MetServe itself is actually a plugin. So maybe we don't need a namespace. Let's just start with an interface. Let's go new item. We're going to have our second interface. Who is it that loved interface? It was Smashery, wasn't it? But I don't think he's on stream tonight. Plugins. Yeah, plugins. So, I mean, as far as MetServe is concerned, plugins don't exist until runtime. So, yeah, I agree. We'll stick with the reference to a plugin. So we're going to have an I plugin. Okay. So the interface to a plugin, which is for now going to remain public, we're going to have a name that needs to have a getter. Okay, so the plugin needs to be able to say, this is who I am. We also know that the plugin itself needs to have an init method. And that init method, as we've already discussed, is going to take a byte array. Can't type. Okay. So it needs to be able to, it needs to know how to initialize itself. Right? And then we basically need to be able to say, I want you to register and unregister yourself in our plugin manager, so to speak, right? So we're going to go void register. Now, here's a question. Should a plugin register itself, or should the plugin expose a list of registrations? I'm kind of thinking it's the other way around, okay? Because let's not forget that in the native Meterpreter, we have different methods / means for a function to run threaded versus non-threaded, and yeah, hang on, maybe I can show you the code for that, Michael. Yeah, this is the fun part. I agree. This is a lot more fun. So what I think we should do is we need to have what is effectively a definition of a plugin sort of hook. So let's create a new type. I'm going to create a new item, and this new item is going to be a class, and it's going to be a plugin function. Okay. Public class plugin function. It's going to be really, really simple. Now, a plugin function needs to describe a few things. So first of all, it needs to have a public string, which is the name of the function. Okay? And that's a getter. Then we're going to have a public bool. Now this boolean needs to indicate whether the function needs to run on the master thread or whether it's running on its own threaded. So we could say, is it blocking or is it non-blocking? Right? Now, actually, we'll have to make this setter as well. So, public bool, let's say it's blocking. Most of them should be false. Okay? Now, from here, what we want to be able to do is go public. We're going to go uint. Actually, no. Do we want to do that? Here we go. Let me have a think. It needs a function. Okay, we need a function that takes a incoming TLV packet and generates a response TLV packet. So let's start with that, okay? So something that's going to take a func, righto. The result is going to be a packet, right? And the value that it's going to take, so that's the first value it's going to take, and then it also returns a packet. Okay? So this is going to be we'll call it handler. Righto. Now, is this going to work? What I'm trying to do is up front, I want to define some metadata. And that metadata is going to say, here are all the functions that we support. Here's whether they're blocking or not. And here's a pointer to the function that I want you to invoke. The problem here is that defining this at compile time might actually be really hard. At which point we may need to, instead of having a metadata like this, I think we're going to have to get rid of this plugin function and do it the other way. Isn't code wonderful? You put all this effort in and then you get rid of it. So let's add another one. Let's add a new item. And here I'm just going to call it a plugin manager. Okay. So a plugin manager is something that's going to allow you to, register a function. So we're going to go public void register function. It's going to give you a name, a boolean, and whether or not something is non-blocking, so if it's blocking or non-blocking, and a function which receives a packet and returns a packet. Okay. Now, we'll have a public plugin manager as our constructor. We're going to have we're going to make this private, actually. Private, what is it? It's going to be a dictionary, isn't it? Maybe what we need to do is have now. Yeah. I'm gonna be filthy here, and I'll tell you why in just a minute. So we're going to have an array of dictionaries. We're going to have a dictionary which is generic. And it's going to be of type string, so the name of the function. Yeah, this is what we're going to do. You're going to hate me for this a little bit, but bear with me, okay? It's going to be a dictionary where you pass in the string, and that gives you like the name of the function. And what it's going to return is whether the function is blocking and the handler for that function, okay? So this is one of the few things, like I wish we had sort of native support for tuples, but I don't think we have them. Ah, shit, we're going to have to create... Oh, that's right. So tuples don't exist until... What was it? .NET 4? Alright, so let's have a private class function definition. Okay. And here we will have a function definition instance. Okay. So... we'll call this handlers. Get, we might just do the lazy loading thing here. If, oops. 4.2, thank you. Yeah, I'm getting way ahead of myself. Plus, to be honest, they're not that great anyway. We can quite easily build our own, but yeah, I'm not going to go down that path. We'll keep it as a strong type. No, I'm not going to do that either. Let's just do the right thing. And go this.handlers equals new. Okay. So this would mean that we would effectively create a new handler on the fly. So we can say this.handlers name equals new function definition, and we can say what is it going to be? Public bool blocking get set. Public func. Now let's just write it out again. Packet, handler get set. Actually, let's make this private. Let's actually wrap this up. Let's make it private and actually have a proper constructor. Okay, so we can go bool blocking func packet handler, and this dot handler equals handler. Making sense? This dot handler should be an array. No, it's a dictionary. So for any given command, we're only going to have one handler, right? Because we're using that as the index, not an identifier like a what's it called? Does that make sense? I guess it doesn't make sense, given that I'm not being very clear. I'll come back to that in just a minute. But the point here is that our plugin manager is only going to allow one handler for every function that's exposed, right? There's something else that I want to get rid of here too. Because I want to be able to handle unregistering things in the same way that the native one does. So we want to be able to remove commands, which is effectively what this is going to be. But behind the scenes, we also need to be able to keep track of which handlers are registered against which extension name. So register function, here we're going to have an extension name, and we're going to have a function name. So this, the handlers for, what's it called? XT function name. The handlers for func name equals that. Does that make sense? So then when we unregister a particular function, that's what we need to be able to do. Do we want to do that for every single one of those? So here's what I'm thinking, by the way. We've also got private dictionary of string, which is the extension, followed by a list of string, which are ext functions. So this dot ext functions equals new. Now we need to keep track of which extensions. Yeah, I was just thinking an array of dictionaries. Do you prefer C# over Python for Meterpreter? I'm not quite sure I understand that question, Devesh. Is that a do I prefer the one language over another in general? Or would I prefer to have a C# version of Meterpreter running over a Python version of Meterpreter running? Tommy, what are you programming? We are building a CLR implementation of Meterpreter. There's the short answer. We'll get that running on CLR 2 and CLR 4. So when we register a function, what we want to do is we want to keep track of which functions are registered to which extension. Because that's accounting that Metasploit is going to ask us for on the fly. Okay? So we want to register a function. We want to give it the extension name, the function name, whether it's blocking or non-blocking, and an actual handler for that function. So How are we doing for time? We've got 15 minutes to go, so I'm going to start wrapping things up very shortly. I want to make sure that the extension, we are keeping track of the extension itself, right? So we can go var, let's go functions equals default list string, and we can say if what am I looking to do? This.ext functions dot try get value for ext name out functions. Okay, so if we don't manage to get one, then functions equals new list of string, and then we're going to actually set this.ext functions to functions. Now we should actually be able to do that at the same time, right? It works the same as C. Is it transitive? No, it's not. Okay, so from here we can go this.ext functions ext name dot add function name. So we are keeping, that shouldn't be functions, that should be func name. We are keeping track of which extensions expose which functions, and keeping track of how to map those functions directly to the handlers, function names to the handlers. Can you make a Meterpreter protocol with Python? You don't get much access over memory in Python from what I know. Oh man, there's more questions. Let me just go over them in order. You're using a green screen. I am using a green screen. I'm using a green screen because OPSEC, and I don't want whatever's behind me to be exposed. What have I done here? Sorry, I'm going to come back to this bit of code in just a sec. Can you explain what a Meterpreter is? Yes, I can, although I have covered this already in part 1 of this series. So if you look back through the Twitch stream, you'll see that part 1, skip part 0, go to part 1 and I actually give an overview of what Meterpreter is. But long and short is it's an agent slash payload that runs on a victim machine once you pop them. Can you make a Meterpreter protocol with Python? Well, Meterpreter has a fixed protocol for its communication, regardless of what platform it's running on. There is already a Python Meterpreter. So if you go back again to part 1 and you look at the rationale behind why we're doing this, you'll probably have the answer to your questions. I'm not sure what you mean by the you don't get much access over memory. That's a confusing statement to me. Perhaps you can explain that a little bit more. Jay is correct. There is a Python Meterpreter already. You can implement the protocol in any language, exactly. I live in a blue screen of death, exactly. Foosball is still over there, don't you worry. It is a session. Thank you. Yep. Meterpreter is an agent that has a fixed protocol. Regardless of the platform it's running on, it has to talk to Metasploit in the same way. Righto, so what I want to be able to do is functions is a new list of a string. Actually, I don't even need to do this. Let's do this a different way. If this.ext functions.has, contains key ext name, so that determines whether it exists or not. So if it doesn't exist, I'm going to do this. Equals new list of string. So there we're accounting for which functions exist for which extension, and we're mapping those functions to a function definition. Yes, I wish it was. So when we unregister a function, we also need to be able to know maybe I can actually do this accounting a little bit better. Public Actually, you know what? I keep saying func name. It's not. It's a method. Method is what it is, remember, behind the scenes. Private set, public string, ext name, get set. So I'm gonna pass all of this stuff through, right? So let's go ext name and string method. This dot ext name equals ext name. This dot method equals method. All right, so I'm going to make sure that this is actually completely passed in, so we can get rid of all of that stuff there. Function definition. I'm just going to pass it all the way down. Func name. Oh no, method. Method is what we're going to call it. Interpreter protocol. So no other questions. So I'm still going to index based on the method because that's the most frequent thing that we're using. Okay. With this plugin manager, we're going to need to be able to say, right, I want you to invoke. So, for example, public packet invoke handler string method packet request. Okay, so here's what we're going to do is we're going to say var fd for function definition. Okay, and then if this dot handlers dot try get value for the method, if we get a reference to it, and we go out fd, that means we found the handler. So then we should be able to go return fd dot handler, give it the incoming request, and it should return the response. Otherwise, we didn't find it, so just return null. Okay, does that make sense? So then once we've got our plugin manager running, we can just go, hey, I've just pulled a TLV packet in. In fact, we don't even need to do this, right? We can just say, invoke the handler for this request, because we can go var method equals request dot method. Oh, it's even baked into the type. Isn't that wonderful? Check that out. It's glorious, isn't it? It's like we thought about it. So we had already exposed on the packet the TLV method. That's glorious. Is there a big difference between setting a variable using a default value of a class instead of setting it to null? I understand it if it were to be a struct. It's just force of habit, really. I guess. I mean, okay, so the other ways that you can do this would be function definition whatever equals null. I just prefer this. I don't want to know what the default implementation is. I don't want to know what the default value is. So if I wanted to go x equals default int, I don't want to know what that is. I don't care. I just want whatever the default is to be that. That's just a habit that I've grown into over my time of writing .NET code. It's just, I don't know whether there's an advantage to it or not. So yeah, I know that's a bit of a shit answer. Sorry. So what I'm going to do here is I'm going to also, because I know I'm going to need this. Actually, no, I know I'm going to need it, but I'm not going to do it now because we're running out of time, and I really shouldn't go and over-engineer or get ahead of myself. We'll cross that bridge later on when we come to it. So we can register functions, we can unregister functions. That's all good. I don't think it's got anything to do with reserving memory. This is just syntactic sugar by the compiler. It doesn't affect like the underlying code itself. So it's more syntax than anything else. Okay, so we've got this plugin manager, and then what would actually happen behind the scenes in our server is when we've loaded an extension, we want to iterate. Once we've created the extension, we want to be able to say, okay, once you've created your own type, we want to get an instance of whatever type it is that you have running, and then call the initialization and whatnot functions on it for each one of the plugins. Okay, so that still needs to be there. We're going to have a void register, and we're going to pass a reference to a plugin manager, and we're also going to have an unregister. And so that basically means we can say, right, here's a plugin manager. You should go and add all of your metadata to yourself. So for every function that they have present, we should be able to just go through and go, right, add, core migrate to this handler over here, all that sort of stuff. And so that's what a plugin interface needs to support. Anti-AV detection methods. Nope. No, I am not. So let's not get ahead of ourselves. Right now, what we're looking to build is the core Meterpreter functionality. All of the evasion and whatnot is actually a different problem. In the same way as it is for Meterpreter as it currently stands on other platforms. So there we go. Look, I think we've got to a point here where this all builds. We've explored the process of staging a little bit more. Hopefully we've got a little more understanding of how that works. We're starting to figure out how we can go from configuration to having a configured Meterpreter with a transport at the top level. And we're going to start supporting the notion of extensions. And I would say over the next couple of streams, very quickly, we're going to get to a point where we go, right, let's build an empty extension, which is standard API, which doesn't really do anything. And then let's also start working out on the Metasploit side how we can marry these two ends up, and we can start a bit of communication going back and forth. Okay. So that's another 2 hours down. That's gone very, very quickly. I could quite happily continue, but as I've said on previous streams, I'm going to be a very good boy, and I'm going to continue to stop at the 2 hour mark. So I will stop there and say thank you again for everyone for coming along and listening to me rant and drone on while I'm bashing out some rudimentary C# code. Hopefully you guys have got something out of it, like the whole extension initialization stuff. We need to push 3 hour limit. No, I can't do it, man. You see, if I'm going to continue streaming 3 times a week, I can't stop at 11 o'clock at night. It will kill me, because it takes me like half an hour of uploading stuff and making sure all the collections of YouTube and Vimeo and Twitch are updated with all of the other crap and blah blah. So I have to stop at 2, because I'll still be up for the next hour making sure that all of the other bits and pieces are in, and that the source code is uploaded and the readme is done and all that sort of stuff. So it's my cat's birthday today, 24. You know what, maybe one day, I think we've already spoken about this, for charity maybe I'd do like a full day of dev with a couple of breaks for lunch and tea and all that sort of stuff along the way. So yeah. All right, thanks guys and girls. Thank you for the subs. Thank you for the follows. Thank you for the support. Thank you for the questions. Thanks for everyone being nice to each other and not being jerks. I appreciate you coming along and joining in, and I look forward to seeing you again in a couple of days. So in the meantime, be good. Keep drinking tea. Stay cool. Catch you next time.